Hello, welcome to this new Harfang3D tutorial in Python. Today we will see how to display a cube with Harfang3D. We will start by importing Harfang. Harfang as HG. We initialize the inputs. Input init. The only reason why we need input here is to be able to catch the escape key and quit the program. We initialize the window system, window system init. Then we initialize the renderer equal 1280 by 720. Window equal hg.renderInit Harfang display a cube, the title of our window, the dimensions of the window, y, and a parameter that we'll come back to later. We will then create our main loop while not ag.read keyboard. We will wait for the user to press the escape key to exit the program. Key ag.key escape. The update of the window, update window, and when we quit the program, hg.render shut down. Destroy window. We have our basic program that displays our window. Now we can start to display our cube. The first thing we need is shaders. Under Harfang3D, the shaders, in their minimal form in any case, consist of three files. We have the fragment shader, the vertex shader, and a file to define the varyings. So the shaders, we will put them in a directory assets for the resources. Here is the vertex shader, which in its simplest form is simply used to calculate the position of the vertices of the cube in space. We have our fragment shader next. The fragment shader which defines a linear light source, the color of the cube material, it performs a linear lighting calculation, and finally it calculates the color of the fragment. And finally we have our varyings definition file. Here we have three varyings. We will come back in a later tutorial on the structure of this file. In the fragment shader and in the vertex shader, you can see that there is an include. Harfang3D works with the BGFX library, so we need an include that defines the BGFX environment of the shaders. This file, bgfx_shader.sh, you can find on GitHub in the repo Harfang3D Harfang Core package. This is a repo that contains the basic resources needed for Harfang3D. Our file will be in shaders, bgfx_shader.sh. We put in raw mode to be able to download it. Display a cube assets, I save. And here is our file bgfx_shader.sh downloaded. So I'm not going to go into the details of this file, it's going to be way out of the scope of this tutorial. Now that we have downloaded the shaders, we will have to compile them. So that Harfang3D can use our resources, it needs to go through a compilation phase. And for that, we will use the assetc API. To download assetc, you just have to go on the Harfang3D website. In the download Harfang framework section, and I choose the good version of assetc. I'm under Windows 64, so I take this version of assetc. So I downloaded assetc here. I unarchive it. I open it in a new window, and I just have to move my assets directory on the assetc executable. And the assets are automatically compiled in the right place. We have everything we need, so we can load our shader. Shader equal hg.load program from file assets compiled mdl. There is no need to put any extension. Harfang will automatically load the 3 files that make up the shader. Then we need to create a vertex model. Indeed, vertices can have several properties. So of course there is a position in space, there is the normal of the vertex, there could also be a color by vertex and so on, and we need to define this model. VTX layout equal hg.vertex layout pose for position, which will be made of floats, norm for normal, which will be made of unsigned integers on 8 bits. Finally, we will create our cube model, cube mdl equal hg.create cube model, the vertex model, VTX layout, and the dimensions of the cube. We will do 1 by 1 by 1. To display the cube, we will need to initialize a view. So to know what views are, I refer you to the video whose links you will find in the comments. So we will use the view number 0, view ID equal 0. We will define the point of view, that's to say the position of the camera. Viewpoint equal hg.translation mat4 hg.vex3. So we will put it at a position 0 on X, at 8 of 1, and a position -3 on Z. Then we initialize the view matrix of the view, set view perspective. It's a function that will allow us to calculate this view matrix. So we give it the view ID, the size of the view rectangle, res X, res Y, and finally the position of the camera that we have defined just above. Finally, we delete the content of the view, set view clear, view ID, the mask to know which part of the view we delete, color on the buffer, hg.cf depth, and finally a background color. We will not put black, we will put, for example, a kind of purple, .2. And finally, we're going to display our cube, so our model, draw model, view ID, we give it the model, cube MDL that we created a little bit above. We tell it which shader to use, so the shader that we have loaded here. Then we have two fields that are used to pass uniforms and textures for the shader, but since we use neither one nor the other, we enter empty lists. And finally, the matrix of the cube. Transformation mat4. The position hg.vec3 0 will put it at a height of 1 and a depth of 0. hg.deg3, we will give it a rotation, for example 45, 22.5 and 15. And finally, we will tell Harfang to display the frame. And we have our cube displayed on the screen. So now we are going to add some animation. We are going to make the cube move. So we'll define a rotation angle, angle equals 0, dt equal hg.tick clock to have a clock, angle equal angle plus hg.time to sec f dt, because the dt is given in nanoseconds and we need to transform it into seconds. And so we are going to replace the angles here with our famous variable angle, angle, angle. So we have the cube here that moves. So it moves very slowly, which allows us to see here that there are pixels. We see a pixelization. This is what we call aliasing. To remove this aliasing, we are going to use the field here. For the moment, it is set to none. That is to say that there is no anti-aliasing defined. But it's when we initialize the renderer that we tell it the level of anti-aliasing we want. MSAA, so anti-aliasing times 8, for example. And then we see our cube moving, and there is no more pixelization. So we are going to make it move a little bit faster now, times 50. And we have a cube display on the screen that turns. And that's it. This tutorial is now over. You can subscribe if you want. Don't forget to activate the bell to flatter the algorithm of YouTube. See you soon for a new tutorial.